Today, we're diving into a thesis paper that, and I'm not exaggerating, describes a totally new way of thinking about energy. We're not talking about a better battery or a more efficient solar panel, no. This is about controlling and moving energy at the most fundamental level you can imagine, using the very weird rules of quantum mechanics. Let's get into how this could literally change, well, everything.
Just think about that for a second. What would that mean? No more power lines losing energy over hundreds of miles. No more charging cables. Just the raw ability to send power from point A to point B, precisely and wirelessly. This isn't some far-off sci-fi dream. It's the core promise of the technology we're talking about today. Entanglement-directed photonic energy transfer, or EDP for short.
Okay, to really get how this works, we have to wrap our heads around one key idea: quantum entanglement. You've probably heard of it. Einstein famously called it spooky action at a distance, and that's a pretty good description. It's like an unbreakable, invisible connection between two particles. You can do something to one particle, and its partner instantly reacts in a corresponding way, even if it's on the other side of the galaxy.
So here's how we're going to break this down. First, we'll cover the big idea, how you can use entanglement like a steering wheel for energy. Then, we'll look at the actual machine they designed to do it. After that, we'll get into the quantum tricks this thing can perform, the very real problems it solves. And finally, we'll zoom out and look at the incredible future it might just unlock.
Right, so the huge breakthrough in this paper is using that spooky action for something new. It's not just about sending information anymore. It's about physically grabbing the flow of energy and telling it exactly where to go. You create this special entangled state where the energy basically hasn't decided which path to take, and you get to make that decision for it. And here is the secret sauce, the math behind the magic. Don't worry, it's simpler than it looks. Imagine energy has two possible roads it can travel down, path A and path B. See that little alpha symbol? That's the control knob. It lets you decide the probability of the energy taking one path over the other. By tuning alpha, you can precisely control, down to the percentage point, how much energy flows down each path.
And here's what that looks like in practice. By setting that alpha knob to a specific value, they were able to force 92% of the energy, in this case carried by photons, particles of light, down one specific channel. The energy isn't just leaking out everywhere, it's being steered with unbelievable precision. Think of it like a quantum-level fire hose you can aim wherever you want.
Okay, so the idea is powerful, but how do you actually build something that can do this? Let's talk about the machine itself, the physical device that makes all of this a reality.
At the very heart of this quantum router is a totally custom material, graphene, that's been carefully injected with specific lithium and nitrogen atoms. You can't just buy this off the shelf. It's a platform engineered at the atomic level, designed for one purpose: to create the super high-quality entangled photon pairs you need for this to even have a chance of working.
And the quality they managed to get is just staggering. A 99.8% entanglement fidelity. You can think of fidelity as the signal strength of that invisible link. At 99.8%, the connection is practically perfect. There is almost zero static on the line, which is absolutely critical if you want to control energy without losing it or making errors.
Now, this is the physical part that actually turns that alpha knob we talked about. The asymmetric coupler is the piece of the machine that acts as the steering wheel. It's what dynamically changes the entanglement to direct the flow of energy from one moment to the next.
And it is absurdly fast. A tuning speed of 1 gigahertz means this router can switch the direction of energy a billion times every single second. To put that into perspective, that's way faster than the refresh rate of the very screen you're watching this on. This is a level of control that's just not possible with any normal classical technology.
Okay, so we've got the big idea, and we've got the machine. Now let's get to the really fun part, the part that feels like magic. The new capabilities, the quantum energy tricks that this thing can do.
First up, energy teleportation. I know, it sounds like it's straight out of Star Trek, but the paper lays out a clear, 4-step recipe. You start with your entangled particles. You encode the energy you want to send onto one of them. Then you perform a special kind of measurement, and based on the result of that measurement, the energy is instantly reconstructed at the destination. It doesn't travel through the space in between, it just appears over there.
And the result? It's a near-perfect transfer. The paper reports a teleportation fidelity of over 99.9%. That means the energy state that arrives at the destination is an almost identical twin to the one that left, with practically zero loss along the way.
All right, the next trick is energy concentration.
So what if you have a bunch of weak, scattered energy, like low-level waste heat? This protocol uses entanglement to gather up the energy from a whole bunch of weak photons and combine it all into a single, powerful, high-energy photon. It's like taking the light from 10 dim flashlights and focusing it into one powerful laser beam.
So how well does this work? Well, the researchers hit a 72% efficiency for a 10-to-1 concentration. That is a total game changer. It means you can take energy that was previously too weak or too chaotic to be useful and turn it into something potent.
Now, this is not just some cool physics experiment for the lab. The whole point of the paper is to apply this technology to solve some of the biggest, most difficult challenges we face in areas like quantum computing right now.
A massive problem for any computer, whether it's quantum or classical, is waste heat. The best methods we have right now to recycle that heat max out at around 35% efficiency. But this entanglement-directed method, it achieves an incredible 82% efficiency. That is more than double the performance.
And this is where it gets truly wild. It's not just about recycling energy that's already in the system. The paper shows how this device can actually harvest new energy directly from the quantum vacuum. Physics tells us that even empty space is buzzing with tiny energy fluctuations. It's normally random and chaotic, but by using entanglement, they can capture these fluctuations and steer them into a usable form. They are literally pulling power out of thin air.
And this table really tells the story. Just look at that last column. We are not talking about small incremental improvements here. Coherence preservation, which is the ability to keep a quantum state stable, the absolute bedrock of quantum computing, is improved by a factor of 42. The time it takes to reroute energy is 150 times faster. These are staggering, order-of-magnitude leaps forward.
So, let's zoom all the way out. What does this all add up to? The paper makes a bold argument. This isn't just about managing energy better, it's about creating systems that don't need to be plugged in at all.
And the potential applications go way beyond computers. I mean, imagine targeted drug delivery that's activated by a precise beam of energy, or satellites in a constellation sharing power with each other instantly with no physical connection. You could be talking about stimulating neurons without brain implants, or even a global distributed quantum energy grid.
And this, right here, is the ultimate goal, the ultimate payoff. The paper modeled a 1,000,000-qubit quantum computer. That first bar, that's the 7.2 watts it needs to run. But that second bar, that's the 8.5 watts the system can generate itself from waste heat and vacuum energy. It produces more power than it consumes. It becomes energy autonomous.
This work completely shifts our perspective. Energy stops being this limited thing we have to generate and transport, and it starts becoming a quantum resource that we can create, direct, and even teleport whenever we need it. So the real question this leaves us with isn't just about what this technology can do, but what will we do when one of humanity's most fundamental limitations is finally removed?